So in this session, I want to talk about DeployR. For those that aren't familiar with DeployR, it's a new OS deployment solution being created by Tupite, where myself and Gary Block and Mike Terrell and Andreas Hammerskold and a whole bunch of others are working on a variety of technologies. But in this case, this one around OS deployment should kind of look familiar to a number of people, but we'll take a look at the capabilities and where we're planning to go with that. From a background perspective, I know we've heard a lot about modern deployment and how you don't need to do bare metal anymore. So it's probably useful to start off with just level setting. Why do you need to do bare metal? There are three main scenarios overall. There are cases where you don't like what shipped on the device from the OEMs, so you had to load a clean OS to get rid of the bloatware. Maybe you want to do additional customization to speed up the process. It's always a trade-off between time and, primarily on time to use a provisioning process to layer everything on once the device is booted up, rather than just laying down an image that already has all that stuff pre-installed, especially if you're talking call centers and classrooms and other devices where you really just want to get the device quickly back up and running. There are cases where you want to change the SKU or the Windows edition or even the version that ships on the device. Some devices ship with versions that are too old. Some ship with versions that are too new. OEMs don't necessarily have the ability to ship exactly the SKU or version of Windows that you want. OEMs also don't tend to keep recovery media up to date. So let's say you have a device, hard drive fails, you want to recover it from media. Sure, you can do that. Recover it to Windows 10 21 H2 and then have to upgrade it several times to get it back to the current state. So there are certainly cases like that where you just want to be able to put a clean OS back onto the device. That does tie into break fix as well. There are some cases where you lose the hard drive. There's no way to avoid having to re-image the device. There are cases where the device just seems to not be working well. It's not worth troubleshooting anymore. Let's just start from scratch. You can do a reset. I haven't done one in the last few months, but the last time I tried it, it was like a 45-minute process to reset a machine versus like 10 to re-image it. So there are certainly cases where it's a lot faster to start from scratch using a bare metal process rather than resetting. Generally, break fix, small number of devices every day, clean OS install if you're doing it for the purposes described. Maybe you do that for every new device and then never again. The third scenario that I think everyone realized after the CrowdStrike incident is there is always the case where a cyber attack or malware or a bad patch or something kills every machine in your environment. And you probably should have a contingency plan for that to say, how the hell would I get every device back up and running in my environment in a short period of time? You're certainly not going to do that from the cloud. You're not going to do that by running around with USB keys. So what's the fallback mechanism in those cases? So really, we're looking at all of those scenarios and what can we do to provide a solution for that. Things have evolved. Like when I started working on OS deployment in the 90s, the challenges that we had to deal with then are not like the challenges today. At least now we have fast networks, and it's quite possible to deploy large images, but at the same time, there are now offices that don't have any Ethernet connectivity at all. So can you do this over Wi-Fi? There are people who work from home, so can you deploy an OS over an internet connection? There are ARM64 devices, which are a fun challenge altogether just to lay down a new image on those. Entra ID certainly is an issue, 8021x, proxy servers, guest networks, all of that stuff is complicating. So we had to try to build a solution that can handle all of those different things. Now, at least we don't have to worry about 32-bit anymore. All OSs are 64-bit now. Yeah, maybe you still got some 32-bit Windows 10 around, but it's probably time to give up on those and move to Windows 11. BIOS versus UEFI. Yeah, you could still use legacy BIOS on devices as well, but really everything should use UEFI. So at least there's some older garbage that we can kind of get rid of to simplify this process. But there are plenty of new complications to take the place of what we've lost. What kind of spurred things along was this move by Microsoft to deprecate MDT. And in typical Microsoft style, the statements aren't very clear. Like, here's what was published in the release notes for Config Manager. MDT integration with CM and standalone is no longer supported with Config Manager, with the first release after October 10th, 2025. So it was announced in December 2024, will happen in October 2025. So if you're integrating it with Config Manager, you basically had to get it out of there by October of this year. The weird statement, that the part of that though, is this and standalone part. What exactly does that mean? And you can read all sorts of things into that, but we basically have assumed that that means after October 2025, when Windows 10 goes out of support, and since MDT has never supported Windows 11, what's there left for MDT to do after that point? So effectively, MDT itself as a whole is end of support in October 2025. So for a lot of people that are still using MDT today to deploy Windows 10 and Windows 11, even though it's not supported, they're starting to look at what can we do to replace it with something that can provide similar capabilities. So that's kind of the background of what we've been looking at. We've been trying to create a new solution from ground up called DeployR. It is a bare metal OSD solution, but it's very similar to what you would be used to today with MDT. It has a task sequence engine, in this case, very much PowerShell focused rather than VB script. It has a user interface. Obviously, we can't use a MMC snap-in. That wouldn't be particularly a good thing to do at this point in time. So we have a web-based user interface for maintaining task sequences. So with those components, then we can put together the necessary support to do that bare metal deployment. If we did this kind of in a vacuum and built out our own task sequence steps and scripts and all that kind of stuff, that wouldn't be terribly useful. So overall is to build this out as a community platform so that you could add in your own scripts and even UI components into the solution as well. It's certainly a work in progress. We've started about a year ago. We're getting to the point now where we're starting to test with customers, but we still have plenty of work to do. So we'll talk about where our progress is and kind of the direction that we want to go as well. If you look at the 2Pint software stack overall, there are a variety of components. The one that's been around the longest is iPixie Anywhere. That is a Pixie solution that uses the iPixie open source software to easily bootstrap a device, but then it ties in some web services on the back end to let you customize the experience to display menus and to do authentication and other sorts of things. So we can see bits of that as we go through the demos. There's DeployR, which is more of a bandwidth management solution for trying to get the best efficiency out of delivery optimization, branch cache, and other random downloads that Windows and software that runs on top of it have a habit of doing. And then RecoverR is another piece that we want to build on top of both, well, really on top of all of these solutions to let you do easy bare metal recovery, leveraging the firmware of the device to help with that solution. So all of the firmware in Dell, HP, Lenovo devices today have networking capabilities. They're able to boot from the cloud. So imagine just being able to boot up a device, hit a key, have it download Windows PE from the internet, and pull the rest of what it needs via a DeployR task sequence down to the device. So those are the sorts of things that we want to do. In today's session, we'll focus primarily on DeployR. You will see bits and pieces of the others as we go along, just because they tend to have some complementary functionality. So our core components, we do have a task sequence engine that runs in Windows PE and in the full OS, very similar to what you would see in MDT. It knows how to execute steps with conditions and reboot handling and task sequence variables and all that kind of stuff. That environment storage makes sure that any task sequence variables that are set are persisted through the whole process. We've built a new progress UI for tracking, even built in a debugger into the process. So we'll take a look at the first pieces of that as we go through too. Again, everything PowerShell based. We decided early on, let's try to do PowerShell 7 for pretty much everything. So we can get away from even legacy PowerShell 5.1 stuff and take advantage of the new capabilities in PowerShell 7. On the back end, we have a database, typically SQL Server, that's used to store all the metadata. We have a content storage location for all the different types of things that we need to download, like OSs and driver packs and that sort of thing, applications. We have the user interface, just a web page for maintaining everything, and we'll see that as we go through too. We expect to build out a set of online services to allow the community to publish their own step types and scripts and sample task sequences and that sort of thing to enable everyone to collaborate on building out OS deployment solutions. MDT was all about SMB communication. No more of that. So everything that we're doing is HTTPS based. We'll support peering via branch cache. So we can do peer-to-peer sharing of boot images and OS images, driver packs, and everything else, so that it's very scalable. Even with a single server serving out all the content, it can be helped out with all the other clients that have previously downloaded the content, sharing that content with other machines. We could support PXE booted devices using iPXE Anywhere. So we hit the necessary keystroke, we PXE boot the device, it talks to iPXE Anywhere, that sends down a DeployR boot image, and then DeployR can run the task sequence. Or we could also do USB booted devices where you just build out a USB key, either containing the DeployR boot image directly, or you could even build a USB key that contains the iPXE files and have the iPXE process download the boot image from the DeployR server. So if you don't want to worry about keeping a USB device updated with the latest boot image, you could just put iPXE Anywhere on it, which is a tiny binary that's really easy to load off of a USB key. So plenty of options. We do build on top of DeployR for the user interface. Eventually, you'll see the DeployR product kind of split in two, with part of it being a platform layer called Platform R, and then DeployR runs on top of that. But For right now, it is one and the same, and DeployR is just a component inside of there.
Michael, there is a question on the significance of the R on the end of every product.
I had to talk to Andreas about that one. The Stifle R was the original one. And I think that was a play on the American Pie movies with Stifler's mom.
Yeah.
And since then, it's just become a bit of a pattern. But
burn his legs. Yeah.
There's also another piece involved in the technology stack. There's a product from Microsoft technology called SignalR. SignalR is a messaging platform, which is what StifleR uses to communicate. So it's really a combination of those two. But yeah, it's an interesting naming pattern, but it gets a little stressed sometimes. Like iPixie Anywhere doesn't follow that pattern. They would like to rename iPixie Anywhere to BootR. So it'd be Booter.
Booter.
All right. So yeah, if you don't like the names, complain to Andreas. We do expect to have multiple versions of DeployR. So we'll have a fully supported enterprise version with all the bells and whistles and integration with all the rest of the 2Pint software stack. We are looking at pay-as-you-go options for more of the technicians and MCP partner-based setups, and then also looking at a free community version that removes some of the other more complex pieces that would integrate with other things, but still provides all the core functionality. So we're still working on defining what's where, but the basic idea is that most of the functionality is core to the product in all the additions. We do want to provide all the expected functionality, ARM64 support, different OS versions, driver management. We want to be able to hook in autopilot scenarios and pull drivers from the web and manually manage drivers and all sorts of things. So all of that certainly within scope. There are some things that we leverage from others, like Pixie. We use iPixie Anywhere to do that. That's not part of DeployR directly. It's just a complementary piece with iPixie Anywhere. In the MDT case, right now, we've worked on a solution called PSD. A lot of the 2Pint people have been working on that, the PowerShell deployment kit that layers on top of MDT. We hope to re-host that on top of DeployR at some point. That will be a fairly sizable effort because of the integrations between PSD and the MDT metadata. We have to replace all those MDT metadata references to DeployR web service calls, but certainly our intention is that we could run PSD on top of DeployR so that when MDT goes away, PSD can continue on as well. So we're looking at that. We've built out some like workflow type capabilities in here as well. One of the things that we noticed was that customers went through processes where they would build out a task sequence as kind of a in development task sequence. They would test that out, and then when it was done testing, they would make that the production one, and eventually that one would then be sunset and replaced by the next version coming through. So we made sure that we supported versioning of everything inside of the product. So you can have task sequence versions, content versions, driver pack versions, you name it. Everything is versioned so that we can more easily roll out changes and be able to see the older versions of things and compare what was changed between the old version and the new version that might have broken things, or just for basic understanding of what those sorts of changes were. So we want to make that easy. The community-driven part, There's always been a lot of community-driven content that was posted to blogs, but it was always more of a copy-paste activity. So we want to make that a more integrated process. So maybe it's all GitHub hosted content that we can easily pull down and import. So lots of design work going on for that one still. But we end up with task sequences that do the work. Those are broken down into steps. Those steps can pull in operating systems and drivers. It could be on-prem. It could be running in a cloud. Since we support peering, the idea of having lots of gigabytes of data up in the cloud isn't really that far-fetched, since you know that you could get the same content from a peer that had previously downloaded it. So hosting this in your favorite cloud provider is certainly doable as well. We built a UI for creating steps. We'll take a look at that as we get into it, but you could add steps to do pretty much anything you want. It's a self-describing process, no code involved. You just say, here are the types of things that I want to prompt for. Maybe I want a drop down or a checkbox or a text box or something like that. And then it becomes another fill in the blank step in the task sequence editor. So it makes it pretty easy for community authored content to be added into there. We want to do the same thing more on the client side. We haven't built that out yet, but the idea would be you could build your own UI that runs on the client to prompt for additional information there too. So that's still a work in progress. One of the challenges that in an ideal world, that build your own UI would be a web page that runs in Windows PE, but running browser engines in Windows PE is a major headache. So we're still evaluating technology options there. Apps. Our simplest option would be to run apps where you upload the content and then specify the command lines to install them, but there's certainly no reason we can't pull in other types of apps as well. Winget, you could have your own private repository or pull from a public repository. We want to be able to run Intune apps at some point, whether that's you import the Intune Win file and then specify the command line to run against it, or if it's pulling directly from Intune, we're hoping that we can make either of those work. And then on the third-party side, it would be nice in a lot of cases to just say that Pack My PC app or something like that, just run that as part of this task sequence. So integration on that level should be doable as well. All right. So if we were to look at basic process for creating a task sequence and deploying an OS, we would start off in the DeployR console. We have a node in there for DeployR, so we can specify that we want task sequences or content items. We add a content item for the OS that we want to deploy. I can add one for Windows 11 24H2, updated back in January. It is an OS, it's a single file. Once I have that, I can add a new version. So in theory, you could just have a 24H2 OS and then each month download the latest ISO from Microsoft and upload that as a new version each time. Potentially we could automate that too. So we upload that to the server. After it's uploaded, then we can take the next step of creating a task sequence. Call this one build. We can add our first version, which is marked as in development. And from there, we can edit, mark it as active, just so it's available on the client side. Let's start off formatting the disk. And we can add a step to apply the operating system. In there, we specify the image that we had just uploaded, so that 24H2 image. The index inside of that WIM. In this case, we'll choose image 3. We have a few different ways of installing the OS. really, how do we continue the task sequence in the new OS? If you're familiar with MDT, it did auto admin logon. If you're familiar with config manager, it uses setup complete. But there's also a third option of using specialized commands. So we had debated which one should we do in DeployR. Eventually, we just decided we'll do all of them. So you can choose as part of the apply operating system step, how do you want to resume once we get into the new OS? So we prepare the OS to download the metadata, we reboot into the OS. Once we're in the OS, then we can configure the OS. And pretty much that's the complete task sequence. I mean, it's a super simple task sequence, but that's all you need to do to deploy an OS. The next step then, move to the next slide. Click, it starts the video over again. We can boot up a machine. In this case, we'll Pixie boot it, which is leveraging the iPixie Anywhere solution. So we'll get a menu of different things that I can boot. Just choose boot to DeployR. Download the Windows PE boot image. Again, getting most of the content from peers because they've already downloaded the image before. We then boot into Windows PE. From there, we can choose our build task sequence and off we go. Obviously, this is sped up just because we don't want to watch I think it's like a 12-minute video, but we download the content, again, peering as much as we can. In this case, even though I just uploaded this 24H2 OS, so none of the machines have that particular version, other machines have the previous month's 24H2. So we can get like 80% peering, even though no one has peered this particular version, because there's that much in common between the previous month and the new month. The branch cache algorithms for breaking the content into chunks does a really good job of identifying similar chunks between releases, so the peering efficiency is really good. Sadly, delivery optimization isn't nearly as good as that, but branch cache does a really good job. Okay, now we're in the full OS. We finished the task sequence. We're to the desktop. That is the super simple case. Now, if we wanted to do something a little bit more involved, we probably need some drivers and apps. So we can take that existing task sequence and add stuff to it. So first we'll create a driver pack for the machine that I was using, which is a Optiplex 7010. It is driver pack, the folder of content. We create a new version for that. And in that version, we'll specify the manufacturer and model so that we can automatically match that. So any Dell Optiplex Micro 7010 will automatically download and install this particular driver pack once we add a step into the task sequence to do that. So I can choose a folder to upload that. There's a whole bunch of files in that folder. Once we processed all of those, we can say we want to upload all of them. We upload lots of stuff. Once all of that upload is complete, we'll see what the content size is, 764 meg. Now that is compressed. If you looked and saw the file name there, it was a .wim file. So all the folders of content that get uploaded, we turn them into WIM files on the server automatically for efficiency so that we can do deduplication as well as compression. And then when we download them as part of the task sequence, we can reverse that process and expand them back out to a folder. In this case, I'm setting up an app to deploy Office, so I can specify setup.exe/configure config.xml, and then choose the folder containing the full Office install files, upload that, which is a few gigabytes worth of stuff. Three gig to be exact, but again, we combine it all into a WIM, so it's compressed and deduplicated. Now we can go back over to that build task sequence, edit that, and add a step to inject the drivers. We have an option to inject from cloud, which would dynamically download from the OEMs. In this case, we'll just use driver packs that we have locally. So it's more a question of whether you want total control over the drivers or whether you want to just grab the driver pack of the day from the OEM. You can also say that we want to install an app, choose the Office app that we just created. And with that in place, we can save the changes. And at that point, if we do the same OS deployment to a machine, we would have exactly the same user experience. We will just see the additional driver pack and injection and the app install. So we'll speed up the whole process just to get us to that point again, because we don't really need to see most of that. So format, download and apply the operating system. Next step then will be to download the matching driver pack after we apply it. We can also see the logs that we're creating along the way. We chose to use the same CM trace compatible log format as MDT and Config Manager use. We added a basic debugger in at this point, so if we click pause at the end of the current step, it won't run the next step until you say to continue. So it lets you poke around and see what's going on. So as soon as that apply finished, we now see a yellow progress bar saying that we're paused after that step. If we then say continue, it continues on with the next step. Click pause again, it will pause after this one. So we just get the basic ability to pause and resume. Eventually, we'll add single step capabilities into there as well. So we've then downloaded the driver pack for this particular model. We can inject the drivers. Again, we're paused. We can continue. So all of those capabilities are currently in there. Now we'll reboot after injecting the drivers, boot into the new OS, and then install the application that we added. So we'll download the 3 gig of Office content and then kick off the installation for that. That's it. Task sequence is done. So simple things, but we're just working through the basics to make sure that we can get a task sequence to do any sort of thing that you might throw at it. We've had a lot of people who've then said, well, what about autopilot? So how do I do a deployment, a bare metal deployment, but then have the device get into autopilot? So we've built out a task sequence to do that, where the basics of the process are still to format the disk and apply the operating system, but we don't need to go through Ubi. We can configure the machine to that sequence am I looking at? Yeah. So we don't need to have the machine completely build itself. We just will take it where we apply the operating system, inject the drivers, and then reboot to let Ubi do its thing. So it's a bare metal deployment, but followed by just the standard autopilot Ubi flow. So simple enough to do. In this case, we'll download the operating system from the cloud. So from Windows Update, we'll pull the drivers that we can find directly from the OEM, inject those, and then boot into the OS to start with Ubi. So we don't put an unattend in place for that. We just let the normal out-of-box experience flow.
Question says, are we starting with 80 and then adding a certificate for encryption traffic during the rest of the deployment?
Starting in
Port 80, I'm assuming.
Oh,
Starting at 80, yeah.
we prefer TLS, HTTPS, so we would recommend that you use a certificate. You can tell us what certificate to use, but if you really wanted to, you could use HTTP port 80 if you wanted. We typically use port 7281, which we just picked out of the air, but it's configurable, so you can choose what port. We didn't use 80 because people tend to put this on another server, and port 80 is already in use by IIS or something else. We don't use IIS. We run our own web server using .NET Core, so it's easier to use a different port. But we just end up at the start of Ubi, so at that point, we're ready to go through the rest of the autopilot flow. One thing worth looking at over here, the apply operating system from CloudStep shows some of the UI capabilities here. So back up a little further. We have what are basically drop-down lists for the OS that we want to deploy, the version, the SKU that we want to install, the options that we talked about before around Ubi. Same thing with the in the cloud driver case, there's nothing that needs to be configured. We'll just figure out what we can download directly from the OEM. And then at the end of this task sequence, we just set the finish action to reboot the machine, which is how it ends up in Ubi. So the task sequence finishes in Windows PE and then reboots into the full OS. Now the UI that we're seeing here with these drop downs, that's part of the kind of the self-describing step definition setup that we have. So we can look at that step definition. To apply operating system from cloud. And we can basically see that it's just a series of item definitions. So in this case, the OS is a drop-down list. It has a list of values. There's a default one, Windows 11. The versions are drop-down lists. There are text boxes, check boxes, you name it. We can put all of that into there. So in this case, I could create a deploy toaster step definition, which is obviously meaningless, but we can fill in the values that it should display, like a 1 and a 2. We can specify that 1 is the default. We have to give it a name and a description. But just an example to show that we can create custom steps pretty easily in here, called slices. So we've got that step definition. We could then go back to the task sequences and pick a random task sequence and edit it. Or we could then take that new toaster step definition and add it to a task sequence. And normally you would have a step definition that has content associated with it to run the script, and then the script would actually do the thing, but it really just shows that the UI that we're showing here is completely dynamic, and you can add whatever you want into the list here. We looked at that one already.
Yeah, another question I missed a little bit ago. If Microsoft 365 is installed by setup, would those bits be shared via branch cache to other deployed machines?
It depends. If you put all of the content into the DeployR app, we download it via branch cache, and then it would be shared via branch cache for anyone else that does the same thing. If you don't put the setup files in the app, so it's just setup.exe and the config file, then it's going to get downloaded using DO and would get shared via delivery optimization between machines. So
Okay.
just depends on how you configured it.
Okay. I know I paraphrased that, George. I think that hit it. Let me know if you wanted a clarification.
We also fully support ARM64, which is a bit of a headache still. The driver management, especially around Windows PE, is a bit of a pain, but you can create a driver pack containing the necessary drivers for the machine. You can inject the necessary drivers into Windows PE. They just may only work on a subset of machines. We can then do a Pixie boot to an ARM64 Windows PE boot image, and the flow is exactly the same. So download Windows PE, boot into PE, and then run the task sequence to do the rest. So we can choose our ARM64 task sequence. Steps for that are pretty much exactly what we looked at before. Format the disk, download the operating system, apply the operating system, and off we go. The nice thing about the progress display here, we've really done nothing in the scripts to report progress. It's just leveraging the standard PowerShell progress reporting mechanisms to show progress bars. So any PowerShell script that does any sort of progress reporting, it would show up in the user interface. So really easy to do. The goal overall is to try to keep the PowerShell scripts that we're running behind the scenes as simple as possible so that people can actually understand them. One of the complaints with MDT is people look through the task sequence templates that we provided and all the scripts that came with it. It might as well have been a black box because no one could comprehend why are all these steps in there? What do they do? What's all this extra script logic in all of the script files? So if you were to look at the scripts for DeployR, they're super simple, very short. They're very focused. They don't do anything extra that they don't need to. They're just trying to keep this as simple and straightforward as possible. We do plan to support Linux as well. We're still working on the full Linux support, but we started off with a simple scenario to do Chrome OS Flex. If you aren't familiar with Chrome OS Flex, it is a version of Chrome OS designed to run on legacy devices. So maybe you've got some old PCs and you don't know what to do with them now that they don't support Windows 11. You can deploy Chrome OS Flex to them and get a full Chrome OS environment. So in this case, we can say we want to boot to our Linux boot image. Once we're in Linux, we can run the same task sequencing engine that we were looking at before, same user interface, same code actually. From there, we can choose our Chrome OS Flex task sequence and kick that off. So it'll download the Chrome OS Flex image, which is actually in a zip file. We can apply that to the disk using Linux utilities and then do a reboot. After the machine reboots, it boots into Chrome OS Flex. Now that's sped up a little bit. If it were real time, it would take a few minutes, but it's still a super fast process to put an OS on the device where you can easily get to a browser and to the network. So good option if you've got old hardware that you want to be able to repurpose for just a browsing device. But we should be able to do Red Hat and other OSs like that just by putting in the necessary task sequence steps to do that. As we found out, it's nice and easy using Windows PE and the Microsoft PowerShell commandlets to do things like formatting and partitioning disks on the Windows OS. On Linux, there's no PowerShell support for doing any of that, so we had to kind of create our own for doing that. But The Linux command line utilities all work well, so we can leverage those, but we want to make it a little simpler overall. So that's going to take us probably another quarter to work that out. Before we talk about that, let me switch over to and show a couple of things. This is actually the current version running on a virtual machine on my Mac here, but I asked the UI developer at one point to provide a way to reorder the steps. They said, what if I've got the steps in the wrong order here? So I can edit. He said, okay, the work's done. Like, all right, I still don't see. How do I reorder these steps? He said, oh, just drag and drop them. It's like, really? That would have never occurred to me. So, okay, we can drag that one there. In this case, the reboot should be over here. Sysprep needs to be after the configuration. So really it is as easy as just rearranging things. So maybe that one was supposed to have been there, or maybe it was supposed to have been inside the group. So done a pretty good job of making this as easy as possible to do the editing and configuration through here. So coming along nicely. The scripts that we're talking about, of course, I've got 15 folders open, but none of them actually point to there. So let me go to the types of scripts that we're talking about, like to format the disk. Simple one. That's the entire script. Basically, it gets the disk index, it calculates the size of the partitions, figures out if it needs to clear it, it does the partitioning, it assigns drive letters, and formats them. That's it. So there's no progress reporting in here. That just happens automatically. There's no explicit logging. Just anything that does a write host ends up in the CM trace compatible log file. So it's all relatively straightforward. Same thing with injecting drivers and installing apps and all the different things that we do. We had figured out that most people just use the default unattend templates. So we've just built in unattend templates for the different scenarios that we support. So if you don't provide your own custom unattend, we'll just use the one that we have. Same thing with setup complete. Well, if you choose to do a setup complete, we have a pre-configured file for doing that. A simple script for installing Windows updates. So all of this is provided with the product and turned into a content item. If we were to look at the right window, we were to look at the content items here, the Windows content package, this 29K of content contains all the different scripts that we're using. If we look at one of the step definitions like apply operating system, it references that DeployR Windows content package and just says that the script to execute is apply.ps1. So that's how it all ties together. Real world. This is my lab environment. If I were to take a machine and boot it up, you can kind of see what the real-time look of that would be. I can pixie boot. Boot to DeployR. I need to investigate why this isn't faster. I think I have one of my peers that's slowing things down, but at least 99% of it is coming from peers, so it doesn't need to pull that from the server, but it'll boot into Windows PE and continue on from there. So we'll let that run for a moment. To it. We are right at the end of Q1, so we're still in the testing phase. We expect to start providing it a little bit more broadly in Q2. We're hoping then in Q3 to have additional options around pay-as-you-go. and potentially Q4 for a community offering for that. But certainly send me an email if you're interested and we can talk. For the full enterprise version, which includes support and all the functionality, the expectation is pricing around $3.75 per machine per year, which if you're used to Microsoft pricing, that's orders of magnitude less than any Microsoft subscription, but that's what we're looking at. We're still working on the packaging and pricing for the other options, but expect more information on that soon. We do have a
575 for the quality guitar for the client for the year. It's different also been top up, or does that include the sticker cost, or is that on top of that again?
It includes the console. It doesn't include the full agent. So that's a separate component. There is a bundle that would include all the different pieces. So there are different ways to package them together.
It's on top of that as well.
We are thinking at this point that the DeployR solution would also include iPixie, the Recover solution for doing recovery from the cloud, and potentially other components as well. So it is a bundle, not just a single product. If you're going to use them together anyway, might as well license them together. We do have a Reddit forum for DeployR. Not much activity, not surprising since aren't many customers using it yet. We do expect to have more to share at the end of April in Paris and then again at MMS, where we'll have a lot of this more narrowed down. We do plan to do another public webinar in second quarter where we'll go through the latest and greatest. You've kind of seen a preview of some of that here, but keep an eye out. Any questions?
Here's one online. Are conditions supported for steps or groups of them, as in, like you get a config and task sequence?
Yeah, so let me go over to, let me kick off this task sequence first of all. Let me run that. We did add condition support, so if we edit this task sequence and go to options, we can have a script condition, which is just run PowerShell and we'll evaluate that to true or false. But we can also do more like a query builder. So we could say model equals multiplex 7010. So you can put in whatever conditions you want. We could add an additional one for manufacturer equals Dell or something like that. You can see some of the debugging logic that's still in there that's showing us the JSON representation of that, but basically that does get evaluated client side. So if that condition didn't apply, then it would skip that step. So it's very similar to MDT and Config Manager that have the conditions in the same place on groups as well as steps. We're just trying to simplify the user experience to make that easier to do. We probably won't put in anything complicated like WMI conditions or anything like that, like Config Manager and MDT have, just because you could use a PowerShell script and do it that way. So we'll just do simple variable tests for conditions. But that is in there.
There's another one. Do we have an interface for staff for provisioning systems to choose different OS apps or computer names?
We're working on it. Like right now, when you boot into Windows PE, the only choice is to choose the task sequence. We want to provide kind of a customized user interface where you could choose from roles and configurations and things like that. So still a work in progress. That one will probably take a little bit more, but we will have the ability to call web services. In fact, I think that's already in there. So you could have a pre-configured database backend that you could call a web service and figure out based on the serial number of the machine. Here's the configuration that it should apply. So
Yeah.
We can do that. It's just the UI takes a little bit more work.
Is there a mechanism to exclude certain clients from being used as the source of the peering?
Can you exclude clients from peering? You can. By default, we download the content. Most of it gets downloaded in Windows PE, the big stuff, and it doesn't get put into the cache of branch cache until it boots into the full OS. So those are actually separate steps. So you could skip that cache stuffing. The other option is you can put a client into local mode. So what does local mode mean in branch cache? It means that if the content is already in the branch cache, it will use it from its own cache, but it'll never share it out to another machine. As opposed to distributed mode, where it does provide, it does offer it out to other machines. Why does that matter? Well, let's say you had a machine that downloaded Office and put it into its local cache, and it's configured in local mode. And now you push out a task sequence to deploy a new version of Office. Odds are that local cache is probably going to have a 50% or more hit rate because it had downloaded the previous content. So it won't need to get all 100% of it from the network. It can get some of it from its local cache based on the chunking that it does. So it is possible, but it's pretty rare to see people do that. As part of the DeployR solution, we do that purposely on like VPN connected machines to say, please, no, don't do peering over VPN. That's a bad thing. But we try to be more intelligent for machines that are on network segments with other machines to set them in distributed mode so they can spread the load. But the default branch cache behavior would be every client that has it is going to share it with any other client that asks for it that can reach it, which would be other machines on the same subnet.
Any more questions? Check one more time online. I think we're good. All right, thanks, Michael.